Hey folks, let's get started. All right, let me post something real quick in this thread, and then we'll get started. All right, cool. So last time we had a lot of really great questions. Really appreciated all the interaction from various people that we were getting in. So that's what study halls are all about. So go ahead and bring your Python questions. Paste them in the thread. If you paste them in the thread, I will see them. I may not see them right away. If I'm working through something else, I'll finish working through that and then come back to the questions as quick as I can. So that is the primary goal that study hall is oriented around, is you bring your questions. If you have any code that you want me to go through and troubleshoot, I can do that. And if not, if you're just like, hey, I'm just stuck on this, send me a link to it in Learn, and like tell me which problem it is. I'll go to the link and just give a solve, talk about the solution, and anybody can ask any questions. Y'all are also free to like help each other out. Just avoid, well, I'm going to be giving answers, but I would say in general avoid giving answers in Slack. But cool. Yeah. So if I don't see any questions, I will go through the material on Learn. Excuse me. Apologies. Looks like we have a few coming in here, so yeah. We got a question about negative modulo. I will give you an answer about negative modulo right now, which is that in all the programming that I've ever done, I've never needed to use negative modulo. So I would say if you're trying to get an understanding of programming, if you know how to use modulo with integers, just move on. You can ask it, although I honestly can't tell you how helpful I'll be. I'm willing to make a fool of myself and take it and explore it because it might be an interesting question anyways. So, oh, and I see you provided some code down below. I'll take a look at that in a second, but just for context sake, yeah, if you understand positive modulo with integers, you know everything you need to know that's really important, at least for our purposes. But there's some other application where that's important. I'm not aware of it. Yeah, let me just pop that code in really quick. Do this without, okay. Download, share file. Slack is not letting me copy, okay. All right, Slack, come on. Please work with me. Sometimes Slack makes things so unnecessarily complicated. Let's see if I can just copy this. View raw. Okay, that'll do. Apologies. So we'll pop this in, give this a quick look. Okay. Oh my gosh. This computer. Give this a quick look and I'll see if I can lend any advice anyways. All right. So 21 mod -5. So the way I always think about modulo, and we'll see if this schema is actually going to work for us here, is it's A over B remainder. It's like if you had something that gave you the remainder of A over B. So 21 divided by -5. I can't even say that I know what that is. So let's look at that. 21 over 5. Let's print that off first. Print 21 over 5. And then let's print 21 mod 5. It should be 1. Oops. A is not defined. Comment that out first. So 21 mod 5 is 4.2. Or excuse me, 21 over 5 is 4.2. 21 mod 5 is 1. 4.2 and 1. And then let's do this with negative numbers. Okay, so 21 over -5. And 21 mod -5, which we know is going to be -4. Oh, it's kind of interesting. It's sort of the complement of the denominator. Yeah, it's interesting. The negative complement. Okay. So 21 over -5 is -4.2. Oh, -4.2. So this is like saying -5 goes into 21 -4.2 times. Oops. Okay. And this is like saying the remainder of -5 into 21 is -4. Yep, I'm not sure that I have anything useful to say about this. Apologies. Other than that this is the behavior and you can play around with it. But yeah, like I said, I honestly just think that this is not going to come up. It's not that important of a thing, so no worries. It's worth playing around with. Sometimes I'll just play around with something and something useful will come out of it. So yeah, I mean, no harm in asking for sure. Could be something fun there. Maybe I'll probably think of a really good answer for this, like the minute that I end study hall stream. If I do, I will I'll paste in a response to this thread and at anybody who's curious. Cool. Yeah, we'll just do that there. All right, we've got another one. So struggling with tuples and indexing, would appreciate a walkthrough of declaring tuples challenge 3. To the asker, can you please give me a link? Because there's multiple places in the material where we'll cover tuples. Like things tend to come up multiple times. It's part of our pedagogy where we'll introduce and reintroduce concepts that we've gone over. You give me a link, I will look at the third challenge there. Write a function called tuphold info. Oh, I'm sorry. You're just giving me the problem statement. Well, that makes it easy. I can do that. Oh, and I got the link too. Thank you very much. It makes it nice and easy. Oh, no, not those. We want these again. Okay. So here is the problem statement. I'm just going to go to the link just so we can submit it once I'm done and verify that Learn is going to take it. Okay, declaring tuples, number 3. Now we this one. Oh, let's see if I can control my computer here. Okay. Okay, so this is the question. And if you have any code you want me to go through, feel free to send that in. If not, that's fine too, and I'll just give a solution for this. So this says write a function called tuple info. I'm gonna, since I know I need to do that, I'm gonna be lazy and just write this in right now. And we'll say def this. I don't know what it's gonna take. Okay. So there's my little quick scaffolding. We'll see what its inputs and outputs are here real quick. Get those in. Write a function called that takes 2 arguments. The first called list. The second called find. Okay, there we go. We'll do list and find. There we go. And then let's do, yeah, I'm not sure what to pass for arguments here. Arguments. I'm going to kind of format this in sort of a docstring way. So here's my sort of name and description section. It's all sort of description. And then here's my argument, 2 arguments. The first called list. So list will hold a list of values. The second called find is a value to find. Okay. Is a value to find presumably within the list argument. This function should return a tuple containing the value that was supposed to be found, the number of times it was found, and a list of the indices where it was found. Okay. So the return, so since I have a few things going on, it's not a whole lot going on, but I can already feel my brain starting to like go, okay, I have to remember something. So if you ever have to think that you have to remember something, just write it down. Just unload that from your brain, right? So I'm just going to take a little note here. I should have some sort of return type that looks like, what was it? See, I already forgot. Here's the dyslexia for you. Okay, so the value that was supposed to be found, that's one thing. We can bullet this. Bullet, oops. Bullet. The number of times it was found. And a list of indices where it was found. The values should be returned in the tuple in that order. Okay, so that's basically find. I'm just going to include find right here. And then the number of times it was found, we can call that the frequency. The frequency and a list of indices where it was found. Element indices. We'll call that LIEX. Short for element indices. Okay, cool. So I have to return a tuple that looks something like this. Okay, so there's my docstring. So I always like to do this, copy paste in the problem statement. And now I just turned this into a docstring, basically. I have a short description. I'm talking about my inputs. I'm talking about my outputs. If at any point I need to like come back and look over this and remind myself what I'm supposed to do, I can just consult this. I have a clear idea of where I'm supposed to end up like this. So now let's think of it of a test for this. But first, so I can't seem to get a list of indices. to count beyond the first instance of the find parameter, which would be expected based on the previous lesson regarding tuple indices. Okay. I'm not sure how to get around this. I'm not sure I fully understand this question. It sounds like can't seem to get a list of indices. Can't seem to get the list of indices to count beyond the first index. Okay, so if the element shows up at index 2 and 4, you're getting 2 but not 4 in the list. That's what I'm hearing. Correct me if I'm wrong on that. Cool. Yeah, just answer that when you get a second. Okay, cool. Oh, and looks like we do have some code, some example code. I see what's happening. Cool. I'm going to, okay, cool. Thanks for confirming. I'm going to show a solution. I'm going to go through my solution, and then I'll compare the code you have to the solution that I have here. So what I always like to do is build up a test. So I'm going to give specific inputs, and for those inputs, I should have a specific output that'll produce. So I'm going to say my list is going to equal, what should it be? Let's do 5. So I'm going to look for 5s here. So I'm going to say my list and 5. Those are going to be my arguments. So my list is going to be my list argument, and then 5 is going to be my find argument. So I've got 1, 2, 3. Am I missing any? Looks good. 5. Okay, cool. So the output should look something, well, it should look exactly like the element to find, which is just going to be there. The its frequency, so that'll be 1, 2, 1, 2, 3, 4. Okay, so I should have a frequency of 4 here, and the indices, which are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 4, 8, 10, 0, 4, 8, 10, and that's going to be in a list. So the list will be 0, 4, 8, 10. Okay, 0, 4, 8, 10. So this, if I've done my thinking correctly here, this is what I expect. Okay, so quick note on this. I'm taking a little extra. I'm making a little extra effort to like go through and talk about and explain the process here. And like if I were actually sitting down, in my own time to do this, I'd be doing what I'm showing much quicker, but I would be doing this in some capacity. Perhaps not quite as thoroughly. I'm trying to be very thorough and talk about what I'm doing for demonstration purposes. But I want you to take note. Look at all the things that I've done. You don't have to take necessarily this much time, but make sure you do these steps. When I saw this problem, I'm not going straight for the definition without having a clear understanding of my problem statement and having a test in place. I have written 0 code towards problem logic, solution logic for this. I haven't even done that yet. So I'm just trying to get a clear sense of where I'm headed. Maybe, with a problem like this, for me, I don't need to quite put this much time into it, but for demonstration purposes, it's useful. So So think about this. Think about like building up some sort of test for a problem like this, or for whatever problems you're solving um, in the future. And this is going to make actually solving the problem a lot easier, right? Even if you have a clear idea of what you think needs to happen, all the time you're like, oh, I know how to do this. And you get halfway through it and you're like, oh, wait, I didn't think of this. And there's something that you didn't account for. Well, now I have a recourse to be able to test this, to be able to see if my assumption about what the solution should be matches the assumption about what the result should be, right? So put a little energy. Doesn't have to be quite as thorough. Doesn't have to take as long as I'm taking, but you know, kind of gussy up your problem statement, make a clear problem statement, and put in at least one test. I could even put in more tests too. That's the nice thing about this. If I wanted to do some other test, let's say I want to do a test for if something is not a member of the list, right? So I don't think I have any ones. Yeah, I don't have any ones in here. So if I have no ones, presumably I should have this output, right? And it's always good to do a test for your sort of edge case, right? I would consider this an edge case because it's like, oh, what if we're looking for a number or an element that's not actually in the list? You know, what behavior do we expect? Maybe we expect it to be an error. Maybe we expect it to do something specific. In this case, I don't see the problem statement specifying anything specific in that particular case. So I imagine this should be the output. 1 is the thing we're looking for. It appeared 0 times, and we have an empty list because that's what we're going to have. Okay, cool. So I've got a couple tests. I've got a clear problem statement. So I've got a function head. So now we can start with the problem logic. So what I'm going to do, like right off the bat, I'm going to think about what are the easy things. And I'm just going to return, or I'm going to write in my return first. So I'm going to say return, what should I call this? Here's the thing. Here's the hardest part of programming, thinking of names for your variables. What should the name for this variable be? It's a tuple. Maybe I should just call it tup. I'm just going to call it tup. I'm lazy. I'm done thinking about it. Okay. Tup equals, so the first element is just going to be find. That's pretty easy. We'll just put find in there right away. The next element is going to be the amount of times the frequency that it shows up. If you ever want to know how many times something appears in a list or a tuple, both lists and tuples and strings. I'm not sure if dictionaries have this method. I think they don't, but lists and tuples and strings definitely do. If you ever want to know how many times an element appears in a list, a tuple, or a string, you can say you name the thing that you're looking in, which in this case is called LST, dot count, and then you count the thing, you pass the thing into count that you want to know the frequency of, which in this case is find. I don't like calling this find. I'm going to call it L for element. I'm going to call it LM for element. Okay. And then the next thing is going to be a list. Okay, so I don't know what should go in the list just yet because we're going to figure that out in a second. But I'm just going to put in an empty list here. And I will refer to this list by saying tup sub 2 because it's the third element in tup. So tup sub 0, tup sub 1, tup sub 2 is going to be that list. Okay. So now what I want to do is I want to go through the elements of the list and I need the indices. So anytime I need the index and the element, I use enumerate. So I'll say for IDX L in enumerate list. So enumerate is going to give me access to the index and the element. And then this is my list that I'm targeting to add things to. And I'm just going to say if L, the element from the list, is equal to, see, variable naming. It's so hard. If it's equal to lm, okay, I'm just going to be verbose. We're going to be verbose. Lm to find. There we go. So if the element from the list is equal to the element to find, we're going to say tup sub 2, which is our list inside of our tuple, dot append. What do I want to append? IDX, the index. Cool. And then I don't need to think about, this is so nice because I think I have a working solution here, and I don't need to go, okay, well, how do I test this? How do I, well, what should I pass this in order to verify that it's working? What should I do? I already have that stuff right here, and I already have an expectation all written out. So this should be a working solution, but let's see, we'll be certain once it runs, one way or the other. So my first one runs and prints out up top here. And for that one, I expected 5 and 4 as the first two elements, and I get 5 and 4 as the first two elements. And then the list should contain 0, 4, 8, and 10, and I get 0, 4, 8, and 10. That looks good. And then the next one, I should get 1, 0, and empty list, and I get 1, 0, and empty list. So these appear to be passing the tests that I wrote. So let's see if Learn agrees. Let's see if Learn is going to agree that this is a working solution. Cool. Looks like I got it. No example given. It's kind of too bad. All right. So I want to paste in, I want to look at the text given here. Oops. So let's look at the function that was given as an example here. So this is taking a little bit of a different tactic. We have this output variable, and then we append define. We have this output variable, and at the end I can see we're going to cast it as a tuple, which is fine. I mean, that's the nice thing about working with lists. You can work with something as a list, and if you need it to be a tuple, you can cast it as a tuple. I just thought of a way that I would rather do this, which I'll just a slight change that I would make to my solution, but I'll get to that after this. Okay. So we return a tuple of whatever the output is. We get empty list here. We append find to it. We append list.count of find. So this is essentially what I'm doing. I'm just doing it in line. Either way, whatever, not a big deal. The difference here is that we're using the index method and appending list.index of find. So index has the behavior of finding the first index of the element passed, right? So the syntax for .index is you have a list and you want to know the index of the first occurrence of an element. So the first index that some element appears in it, right? So you say list.index and then the element to find the index of. But the behavior of index is that it only gives you the first one back. So in this case, the difference here is that I made this for loop. And there we go. I made this for loop here that goes through the whole list, enumerates it. which gives me the index and the element, and then I just check if the element's equal to the element to find and append the index if it is. I don't know why this didn't occur to me. List equals this, list dot append that, and then I can just return this and list. This will have the same effect, and this feels a little cleaner to me. I don't know why I didn't think of this right away. It's a little more generic, a little easier to read. And it also uses this feature of multiple returns. You might think, oh, well, now it's not a tuple anymore because it's not, doesn't have parentheses around it. You can, in this particular context, you can use parentheses or not. Either way, it's going to be read as the same tuple, right? So this is a valid tuple. If you want to return multiple things from your function, you can do that, just comma separate them. And then just remember that Python will assume that this is a tuple. So this is going to work exactly the same as the solution that I had before. To demonstrate, let's just comment this out. Paste that in so the earlier solution is commented out, and that'll run the same. Oops. Yeah, like I said. Ah, very interesting. Well, I broke it somehow. That's pretty fascinating. Now I'm really interested. Why does the one way work and the other one doesn't? Well, that's just fascinating. So it's saying, oh, this is actually kind of cool. So this is saying that it looks like it's running the same test here as I was. So now I'm curious. We have a bug. Let's find it. Let's find out what's going on with this code. Interesting. So I don't get the same results at all as this gets, but I also don't get quite the right result. Element to find, and then list.count. Oh, I'm so silly. I used something called list twice. Oh my gosh, what a ridiculous thing. So that's embarrassing. But also kind of par for the course, you know. So I got too lazy with my variable naming here. If I have a list, I always just call it list. In this case, I didn't distinguish between the input called list and the variable that I'm using as an output also called list. So when I encounter this particular thing, what I like to do is call the input variable in list, and then the internal variable, I'll just call it LST like this. Now I have to go through and make sure that each one is correct. So I want to append to my output list. I want to output my output list. I want to count from in list though. Okay, cool. So that should work. Okay. There we go. Like I said, that's a working solution. Cool. That's a good one. So that's something to watch for. Name conflicts. If you have two things that are the same name, right? Look for where things are being used versus where things are being created, right? So on 48, line 48 here, I'm creating a parameter called inList, or I was creating one called list, right? And then on 49, I was also creating a variable called list, which will overwrite the parameter. So it doesn't let both exist at the same time. It just overwrites the previous one with the most recent one. So that's what caused the problem. So it looks like that's working. Good. Awesome. That was a fun one. Okay, cool. So we got thanks. I got tripped up through the for loops I attempted, but I'm glad to know I was on the right track. Yeah, definitely seemed like a good start on a solution. But yeah, the for loops can be a little tricky to pick up. They can take a little time, especially with enumerate. That can feel tricky. But the thing with enumerate, the thing to remember with enumerate is uh, anytime, or I guess I would say the thing to remember with needing indices is to use enumerate. So anytime you have a problem that says list blah 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 index, you're probably going to use enumerate. Um, if you're working with a list of things and you want to like capture the index of the elements, you need to know an index relative to an element, or you need to, in certain cases where you'd need to like track like your position in the list, which isn't necessarily your index, or your position through some range of elements. So sometimes you might start your the index at a different value other than 0. But yeah, definitely when you need the proper list index, enumerate is really helpful. And the way you can capture that is you can do for a comma b in enumerate, and you can call a or b whatever you want. You can give it any name that you would give any other variable or parameter name. Any valid identifier name would work there. But I like to go with, if I'm just going to use generic names, I will usually just go with IDX for index, because that's a standing convention. People would understand your code if you wrote IDX. It would be clear that you mean to use that as a proper index, which we do in this case. And then element or LM or EL, something like that, or you could spell out ELEMENT if you wanted, although that's kind of long. But if you wrote L or LM, you'd be understood as just meaning element. Often you want to give that second identifier a more meaningful name, because often you're working with a list of numbers, so you might call it number, or FLT for float, or int underscore for int, or string if it's a string, or word if it's a word in a list, right? But in this case, since the elements in the list are arbitrary and there's no mention given as to whether it's going to be a list of strings or whether it's going to have mixed elements, since we don't know what those elements are, I'm just going to use a generic name and call it L. But that's my preference. You can do what you like. Cool. Right, I don't see any other questions in the channel for now. Do feel free, anybody, even if you've asked a question, feel free to bring another one. Yeah, I may or may not, even if I don't necessarily go through a question, you're always free to ask. Yeah. Since I'm not seeing anything at the moment, we can I'm just going to switch gears into going through the material. Oops. Struggling to use my computer here. Okay. So recently in Premium Prep, we went through conditional logic using if, elif, and else. And this isn't necessarily what I would call like, I wouldn't call it like a complicated idea, but there's enough going on that it's worth spending some time on. And it's a very central thing that you need to understand. So even if this is maybe below where you're at a little bit, That's okay. I would just say like hang on anyways if you're new, if you're in premium prep, because it's worth sussing out any, discerning any point of resistance with this stuff and understanding it, because it comes up all the time. Okay, cool. So if statements allow you to run code conditionally. So we can take a look at this code example. And I was giving examples like this where we have a number and we just check if that number is less than, equal to, or greater than some other value. And we'll print the things off accordingly. So the important thing to know, and we can even look at my example up here. We can look at this example that I gave for this one. This uses a single condition. Oops. Let's just look. So in this condition, from my previous solution, I'm saying if element is equal to element defined, right? And element could be a string, it could be an integer, it could be another list or a tuple or whatever. It could be anything. But what I'm looking for in this writing this condition is after the if, I need something that's going to give me a value of true or false, or a value that I can use as true or false, which is most things. So I need to think about this as being true or false. If it's true, the code in the if block is going to run. If it's false, it's just not going to run this code. It'll just skip it. Since that's all there is in the loop, it'll basically just continue on to the next iteration. So that's what's happening with the condition there. So this is how we can discern. This is how we can tell if we should run one specific block of code. But imagine there's something you want to do if the condition is true, and something you want to do. So there's something you want to do only if the condition is true, and there's something you want to do only if the condition is false, right? I think I'm just going to use. I'll just use the simple example. Num equals. We'll do a equals 5, and we'll say if a greater than 10, print a is greater than 10, or just execute some code. So I only want to print a is greater than 10 if a is greater than 10, and else. This is print. A is not. Oops. Wow, what am I doing? Not great. Come on. Okay. Just typing is the challenge right now. A is not greater than 10. So I only want to print A is not greater than 10 if A is not greater than 10, right? So only one of these should run. So that's why I use an else here, because else is going to, the code under the else is only going to run if the prior conditions preceding it in the chain that it ends or false. So this is a chain of 2 conditional blocks. I call them a chain because they're related. The reason that they're related, that they bear on each other, is this else is, the code in this else is influenced by this condition. So If A is not greater than 10, then the else will be activated. So let's run this. Obviously, 5 is not greater than 10, so we're going to run the code in the else block. Right, so this is different than if A is less than or equal, less than or equal to 10. Right, so in this case, only one of these can run since these conditions are sort of mutually exclusive, but that just happens to follow from these conditions. But what if, how would I show this? What if I said, what if I wanted to do if A is less than or equal to 3? How would I do this? Let's do less than 10. Let's do greater than 3. Let's run this. Okay, so in this case, both of these can be true, right? So this is a case where you might want consecutive ifs. So there's valid reason to have an if followed by an if, maybe even perhaps followed by another if, right? So in cases where multiple things can be true and you may want to execute multiple blocks of code, it's valid to use consecutive solitary if statements, right? So these are just, this is not a chain of conditions. What happens, whether this condition is true or false, has no bearing on whether this condition is evaluated or not. So so they're both going to be evaluated regardless of whether the other one is true or false. But let's say I have something where I only want to run one block of code. I only want to run one of these, right? So I might do like an elif, right? And so this will say if A is less than 10, print A is greater, or excuse me, less than 10. And then this should say A is greater than, I didn't change these. That's kind of silly. This will say A is greater than 3. Right, so in this case, perhaps I want to know, okay, it's more important that I know if A is less than 10. If it's less than 10, I don't actually really care if it's greater than 3. You know, I just want to run the code for less than 10, and then I can ignore this other case. So in this case, there's a hierarchy of the code that I care about. I want to know if it's less than 10, and that's more important than if it's greater than 3, even though both of these can be true at the same time in the case of 5. So if it's, under what circumstance does this one run? So if A is not less than 10, well, it has to be greater than or equal to 10. Let's just say 15. So if A is 15, 15 is not less than 10, so this is false. And since this condition was false, then Python is going to go on and evaluate the condition in the elif. It'll be like, okay, that was false. So elif is like saying else if. So else as in, given that the previous condition was false, if, as in check this next condition, right? So elif a is greater than 3, which if it's, well, yeah. Elif a is greater than 3, then print a is greater than 3. So if I run this, we should get a is greater than 3. This is kind of a silly example because what I'm really checking for in this case is if it's greater than or equal to 10, because that code's never going to get checked unless it's greater than or equal to 10. But you could imagine that maybe we have something like this. And these values are determined, by other parts of your program. And you could see this as being potentially a valid scenario. So here's the thing. I know I've touched on this in Premium Prep, but I want to emphasize this again because it's important. You need to think out whether your conditional logic has independent elements where you have multiple things that you might want to do, or if it has well, I said independent. I think the better word would be inclusive, right? So if there are multiple bodies of code that you want to execute, you want to make sure all of those conditions are checked. Otherwise, if there's only one possibility of a number of possibilities that you want to run, you want to chain your conditions with if, elif, and else, right? And you just have to think about that for each problem. There isn't. I see people trying to do this thing, and I remember trying to do it when I was first learning. When I was first learning to code, Python was one of my first languages a long time ago, and then I kind of went to JavaScript and then came back to Python. But I remember going through that like, like what's an easy thing that I can remember? Maybe I should just always use ifs, and I'll just, if or elif and else maybe just make something easier. But I can just think about using if all the time. But that'll lead you down, invariably that'll lead you down the wrong path. So there are times when you need to use a single if. There's times when you need to use multiple ifs. There are times when you need to use if elif. There are times when you need to use if else. And there are times when you have to use if elif else. So all of those scenarios are valid. You just have to think about it for every problem. The thing to remember here is that when you have an elif, the condition in the elif will not be checked at all if the condition in the else it won't be checked if there was a previous condition in the chain that it's in that was true, right? So as soon as it encounters a true expression, it's just going to stop. It's not going to check any of the ones below it, which is useful. You sometimes want that behavior. So you can muse on that to get to mine out the understanding that you need for this. Okay, cool. I shall digress. Awesome. I think this just probably went over all the things that I said. Yeah, this is going over what I just said. All right, so let's actually do these challenges. So write a function called isIt5 that takes in a single number as an input if the number is 5 then the function returns true. If the number is not 5, then the function should return false. Okay. So let's do this. I'm going to show my workflow pattern. This is a very small problem. Oops. But I'm going to just show the workflow pattern anyways. Write a function called isIt5. Takes in a number. Let's test a false case and a true case. So this should give me false. This should give me true. And then we'll say def isIt5 takes in nummy, takes in num, and we'll say if num equals 5, return true, else return false. Yeah, that's one way to do this. False and true. I could use consecutive ifs here. I could say if num not equal 5, although this is this looks wrong to me. This checks explicitly the negative case of this, which means it should just be an else, right? So not equal is all the scenarios that aren't equal. So this should just be an else since it's a catch-all anyways. So this will work though. And if that's what you submit, then, fine, work, if your code works. And don't let me be the judge. This will also work. So if I do an if here, and the reason this will work is if it's true that the number equals 5, then we'll return true. When the function encounters a return, it stops executing code, right? Like it's not going to look at any more code. So if that's true, it's going to run this return true line, and then it's not even going to look at this return false. It's just going to skip it altogether. So if num equals 5, it returns true. If num not equals 5, then it doesn't run this and it runs this instead. So this looks fine to me. I think this would be a valid way of doing this as well, since we're using return to sort of stop the function appropriately. Another kind of hack here, and it's a hack because it sort of defeats the purpose of having this in a lesson about conditions, or if elif else, right? What we can do is return num equals 5. And this is the condition if num equals 5. Well, num equals 5 is an expression that gives me true or false. If num is equal to 5, that gives me true, return true, right? So this is only going to return true when num equals 5 is true, and it's going to return false when num equals 5 is false. So I can just return num equals 5, since that gives me true when I want it to be true and false when I want it to be false. So I can actually shortcut it like this. And this is actually how I would write code that did this, but that'll work as well. I believe learn will accept it like this. I'm going to be ornery and do it like this, because why not? It does not. It got me. False not equal to none. Okay, I missed some condition. If the number is not 5, then the function should return none. Ah, it got me. All right. So it has to return none. I think they did this. Just to spite me personally. No, I'm just kidding. No, but that's what I get for not reading. I didn't even read the full problem statement. How about that? All right. So in this case, I'll try to get it all on one line, just because why not? If we'll say, we'll do this. True. If num equals 5, else. Whoops. else, false. Oops, none. Cool. All right. There's that. I didn't even read the thing. Okay. So this is a ternary statement. For those of you familiar with other languages that have ternaries, this is Python's ternary. If you're not familiar with a ternary, it's a fancy way of compressing an if and an else onto one line. This is identical to saying if num equals 5, return true, else return false. So it's exactly the same as doing that. Cool. Ah. None. Like I said, I keep wanting to return, because if I'm returning true, it's so counterintuitive to return none. Okay, cool. Oh, I just ran it. All right. Challenge 2. What is the value of x after the following code executes? X equals 10 if x is greater than 10, x plus 1. So 10, the question is 10, is the value of x greater than 10? The value of x is 10. Is 10 greater than 10? 10 is not greater than 10. It's equal to 10. So this is false. So this does not execute. So we don't add 1 to x. So the value will be 10. The following code snippet prints the value of x if x is greater than 10. Change the given code to print x if x is less than 10. Okay. In this challenge, you can already assume x is defined before you run the code. Okay, cool. We'll do that. Good. Challenge 4. Following code snippet prints the value of x if x equals 1. Change the code to print the value of x if x does not equal 1. In this challenge, you can assume x is already defined before you run it. So if it's not equal to 1. Just a little quiz on the operators, I suppose. All right. We got another one. Correct the following code to increment x by 1 if and only if x is greater than or equal to 10. So if x greater than or equal to 10, x plus equals 1, was it? It's greater, increment the value of x by 1. Okay. Try that. Cool. This is just kind of quizzing you on the operators. Oh, and we already talked about if, elif, else. Well, let's just see if this has anything useful in it. So by the end of this lesson, you'll be able to describe the conditional keywords and how they work together. Use and understand if, elif, and else to write code that only executes under certain conditions. So look at the example below of a common case form of if and else. So we've got num is some number. We've got num. If num is greater than 30, then we're going to run print num times 3. else if num is not greater than 30, then we'll print, whoops, num plus 90. I think we went over the if and else logic pretty well at this point. Excuse me. Okay. This is a good point. I forgot to mention this. So this code will give an error. This says the else is not preceded by an if or an elif, so it's invalid. Actually, it's preceded by this elif, but we still have the same problem. The elif is not preceded by an if. So you can't start checking conditions with an elif. Elif 10 greater than 5, print 10 is greater than 5. So this will be an error. Just an invalid syntax error. So elif is supposed to check this condition, right? But if you think about this, you're saying elif, but what is it else to? The L part means that the previous, only check this condition when the previous condition was false, but there is no previous condition. So we have to. It can be preceded by another elif, right? Because an elif is a valid condition, but the chain of conditions has to start with an if. And these are dumb because these are silly examples because I'm not going to change the conditions. They're all the same condition, right? But in order for this to be valid, the chain of conditions has to start with an if. So you can see that if I comment it out or get rid of that somehow, the syntax highlighting change in it, I'm used to the way it highlights, so I can tell by looking at this that something's off. So getting used to paying attention to your syntax highlighting can kind of give you little cues like that. So if you want to start a chain of conditions, you start it with an if. The middle of the chain of conditions is comprised of elifs. You can end the chain at any time, but if you end it with an else, what you're saying is, given that all of the other conditions were false, all of the conditions above were false, just run this code instead. So if you end with an else, one of those consequence in one of the conditions will be run. If none of the other conditions were true, then it'll be else. Then the else code will run. So there's certain times when you need to do one of some number of things, one and only one of some number of things. There's certain times where you may need to do one of several things, one and only one of several things. In that latter case, you would just end with an elif, not an else. Yeah, that's silly code. I'm going to delete it. So so just to sum this up, you cannot start a chain of conditions with elif. You cannot start a chain of conditions with else. Neither one will work. Same thing here. Else. What does that mean? Else what? Print. Else. Else what? Or else what? I feel like that's what it's being said. Else, like what is it else to? Another thing to remember, else does not take a condition. Since it's just else, it's its own condition. It's like saying, given that the previous conditions were false. if it's true that all of the previous conditions were false. So else is only there to end a chain. Once you have an else, you don't continue the chain. You can start another chain after it with another if, but you don't continue it with another else or another elif. That chain is terminated. It's over once you hit the else. You can nest conditions inside of each other. So I can have an if inside of an elif or an else. Let's just look at this. So we got num equal to 5. If num is less than or equal to 10, num plus equals 11. If num is less than or equal to 20, num plus equals 5. If num is greater than 20, num started out, it's going to print num started out as less than or equal to 20 and is now greater than 20. So yeah, let's run this for different values of num. So num is equal to 16. So this is going to say, if we start at num is 5, it's going to check num is less than or equal to 10, which is true. So since this is if, elif, else, it's not even going to bother evaluating any of this code. It's not, because it's already determined that these are chained together, therefore only one of the operations can be run. So it's going to look at if num less than or equal to 10. It's going to find that to be true, and then it's going to add 11 to the current value of num, and then it's going to print num equals 16. So let's do num equals 11. Num is less than 20. Okay, so what happens here? It checks if 11 is less than or equal to 10, which is false, so it moves on to the next condition. If num is less than or equal to 20, which is true, then num plus equals 5. 11 plus 5 is 16. Then it checks if 16 is greater than 20. That's false. So then it runs this code instead. So if num is not greater than 20, else print num is less than 20, right? So let's go for that other condition. 15. Oh, actually, this has to be 16. Okay, so this is going to say if 16 is less than or equal to 10, which is false, then it's going to check. It won't run this code. Then it'll check the next condition. If 16 is less than or equal to 20, which is true, then it'll add 5 to 16. 5 plus 16 is 21. Then if 21 is greater than 20, which is also true, print num started out as less than 20, less than or equal to 20, and now num is greater than 20. So it prints that out. Notice how it doesn't print this out, because num is now no longer less than 20. So we don't want to print that out. We'll print this out instead. Then we have one final condition, which is this else right here. And that's if, let's say, we'll start out at 21. So num is greater than 20. So what we do is we say if 21 is greater than 10, which is false, then we move on to the next condition. If 21 is, excuse me, I said greater than, I meant less than. 21 is less than 10, which is false. Less than or equal to 10, which is false. Then we check if 21 is less than or equal to 20, which is also false. So we don't run any of that code. Then we see this else, and this is a catch-all. We don't have a condition here because it doesn't matter. It just is saying, well, whatever it was, just do this instead. So it just says the number is greater than 20. and that's what we see on the output. This is another sort of testing paradigm thing. Notice I'm trying to get my code to explore every avenue of my coding logic here, of my conditional control flow, because I want to make sure that all of it's going to execute. So something good to do. Cool. This is interesting. Let's run this. Okay, so this says, so here we're using if, elif, and else to build a little menu for the user, right? So this is like a little restaurant menu that says choose a food item, burrito, or B for burrito, P for pizza, and S for sandwich. So let's just play around with this. So if I'd say B, what kind of burrito do you like, bean or cheese? Bean and cheese, which is A, or breakfast burrito. Oh, I want a breakfast burrito. That's B. You'll get a breakfast burrito, so I get a breakfast burrito. Okay, let's run this again. Let's see what they have for pizza. What kind of pizza do you like, cheese or pepperoni? I'm going to go for cheese. And I'll get a cheese pizza. And then let's get a sandwich. What kind of sandwich do you like, ham or PB&J? I'll have a ham sandwich. And I'll get a ham sandwich. Run it again. So what if I ask for something that's not P, P, B, P, or S? Let's say I want, I was going to say a salad, which starts with the S, and then pasta, which starts with a P. Let's say, why can't I think of food items right now? Banana. I don't know. So it says, we don't have that. Sorry, we're a crappy restaurant. Cool. So this is just using if, elif, and else. I would say that this is kind of a good reference for, how if, elif, and else relate to each other, right? So this is showing you that, only one of, since these are chained together with if, elif, and else, only one of the things is going to be run, right? If we had done this with all ifs or something, then we might get different behavior. So cool. Oops. Write a function called, let's do our challenges. Write a function called 5 or 3. Takes a number as an argument. Return true if that number is either 5 or 3. Okay, so that's neither 5 nor 3. So let's do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 0. All right. Gosh, we don't need to be that thorough. Could be though. We'll just do 5, 4, and 3 for these ones. Okay, so for 3 we expect true. For 4 we expect false. For 5 we expect true. Okay, so write a function called 5 or 3. The function takes a number and return true if that number is either 5 or 3. If it's neither 5 nor 3, then the function should return false. So this, since this one does return true or false, unlike the previous one that only returned true or none, this one I can do by saying return num in do a test for membership 5 3. True false true. Okay. Cool. So that'll work. So in this case, I can just include a condition that'll, or I can just return a condition that'll give me the right answer. In the spirit of doing this in the way that I'm sure that they wanted us to do this, we could say if num in 5 or 3, oops. If num in 5 or 3 return true, else return false. That'll work too. Then without getting into tests for membership, which we've only talked a little bit about, we can do this, and this is a little bit redundant, but we could do this, elif, right? Do an if, elif, else here. That'd be a way of using if, elif, and else. We could also condense this condition down into one line, since both of the consequence of that were the same thing. We can say if num equals 5 or num equals 3, then return true, else return false. So that's not a bad way to do it. So multiple solutions with that one. And they're going for the if else solution. Oh, we got a full thing here. Okay. Write a function called is divisible by, which takes in 3 parameters, num, divisor 1, divisor 2. Okay. All right. Takes in those 3 things. So we have examples here, and what I'm looking for in the examples is the call to the function, valid parameters, and then some expectation of the output. My personal preference is to have this below, so I'm just going to do that. Oops. I'll do that there. We'll just get rid of that examples. So we'll take this, def, that. What is it, num? Be lazy here. Get rid of the and. That's nice. Okay. So it takes in these 3 parameters. Should check whether the number is divisible by either, unhighlight that, by either of the divisor parameters or both. It should return the following strings as appropriate. This number is divisible by divisor 1. This number is divisible by divisor 2. This number is divisible by divisor 1 and divisor 2. This number is not divisible by either divisor 1 or divisor 2. Okay, cool. So I think I'm just going to copy that and just put this in here and write conditions around it. I think what I want to do, I know that these are going to go in prints, so I'm just going to print, and we'll come back to those in a second. What's that doing there? Aha. Put this in there by accident. Okay. Had that accent in there. Okay. So I'm just going to comment these out and do one at a time. So this number is divisible by divisor 1 if num mod divisor 1 equals 0. So let's just see. So 9 is divisible by 3, but not 2. 3 is divisor 1. Okay. And I know it's not going to say 3 yet, but I just want to make sure that it's going to run the right line of code. Okay, so it looks like we've got none in the other cases. Oh wait, does this want us to return it? It does return. So I said print, and I meant return. It's an important distinction. There we go. Come on. Oh. Okay, that's better. So it looks like, right. So this line of code is working. That's the one I want to do for that one. But it's not the one I want to do for this one. So it looks like I'll need to check if, I'll need to check the both condition first. So let's get this returning the right string though. Let's just focus on this first one and we'll come back to these other ones. But I just wanted to see where it was at. So I'm going to comment those out for now, run that, and we'll just get this one output. There we go. So the number is divisible by divisor 1. Okay, so there's a number of ways we could do this. Actually, let's just do this. I'm going to use an F string. If you're in Premium Prep, we talked about F strings recently. They're a way of, notice how I put this F in front of the string. F string is for a format string, what we call a format string. So you just put an F in front of the string, and notice how that changes the syntax highlighting here. Watch this spot if you didn't see it before. So I'm going to put an F there, and it changes that syntax highlighting. And what it's going to do is it's going to include whatever value divisor 1 has as a variable inside of these curly brackets. The curly brackets are not going to be shown in the final string. So what this should say is this number is divisible by 12, and that's our expectation down here. I don't know why I said 12 by 3. This number is divisible by 3. Cool. So that's working correctly. I did see an issue here where we have 12 is divisible by 3 and 4. Right, so 12 is divisor 1, 4 is divisor 2. So if I run this code, this second test, it's going to tell me it's divisible by divisor 1. And that's not the message that I want to send. I want to say that it's actually divisible by both. So I'm going to return this one. We'll make this an F string. And this is we want to return this if num mod divisor 1 equals 0 and num mod divisor 2 also equals 0. Oops, divisor 2 also equals. So if both of these are true, we want to return this different string. So I'm going to put that up there. I need to check this first. I'm going to chain these together with an elif. I need to check this first. The reason I need to check this first is since we're returning something, as soon as it encounters a return, it's going to stop executing code. And if I check if it's just divisible by divisor 1 first, then it's going to return this and it'll never check the other condition, right? So I have to check if it's divisible by both first. That way this particular condition doesn't get doesn't become meaningless because it's checking the other ones first. Okay, cool. So I think we can just do this. We'll just change this to divisor 2. And now we should have a few of them working. So it says divisible by 3. That's our second divisor in this one. So let's check this one. So 12, 5, 3. 3 is our second one. So 3, 3 and 4, 3, good. And then 12 is neither divisible by 5 nor is it divisible by 7. It says this number is not divisible by either 5 or 7. So that should be this one. And I'll just throw this in an else. Let's do an if or an F. I don't know what's wrong. Like my English skills are not doing great today. Okay. So what do we expect? Divisible by 3 and 4, 3, not divisible by either 5 or 7. And we expect 3, 3 and 4, 3, neither 5 or 7. Good. So that looks like it's working. Well, let's go from there. Wait, what is this trying to tell me? You will likely find F strings. Oh yeah, this is just giving me an example of an F string. Gotcha. Cool, looks like that works. And let's see what their solution is. I think it's exactly the same. Yes, it's exactly the same as mine. Cool. All right. What do we got? We got one more here. Let's just do, yeah, let's do this one more and then we'll wrap up. Just so we can cap off conditions and move on to something else next time. Hello. Okay. Write a function called depends on type. We'll do some type checking. that takes in a single parameter, obj, which is short for object. The function will work on the types Boolean, string, float, or int. What is returned depends on the data type of the object. And I'm going to assume that this is going to, I'll just bullet those. So if it's an int, so I think I'll start doing this. Let's have something with an int, Boolean, string, float, int. So Boolean, string, float, int, true, false, hello, string, float, 4.83, int, and then let's do something that's none of those. How about a list? Okay, so here's my tests. So let's say def takes in obj, and we're going to say if it's an int, if it's a float, if it's a string, if it's a bool, if it's none of those, return none. Okay. So I've got 1, 2, 3, 4, 5 conditions here. So let's do five. I'm going to say if type obj equals, and then I'll just fill those out. We'll just throw a pass in here so I can work on one at a time. So let's see. So, oops, bookmark. There we go. Okay. So why am I having a hard time? Okay, so let's say int. Oops. Float, bool, string, and then what was the other one? Int, float, bool. That was it, right? Int, float, bool, string. Okay, and then none, right? So we'll just say else here for this one. Okay. So for the middle ones, I'm just going to do elif and else. I know I want to return none. Now, I could actually omit the else, return none. This is completely unnecessary, but I'm going to do it just to be explicit about my intention to do that. Otherwise, like leaving it out, is kind of like saying it's not clear that would have been intentional, right? Whereas if I explicitly return none, I'm saying like, yeah, that was my intent. Now, in this case, this is just a problem for learn. Like, who cares? This isn't existing in like a huge code base. This is just kind of a silly, fun problem. But it's good to practice like thinking about like how you're communicating in your code, what you're making clear and what lines of code, right? So if maintenance were ever going to be an issue on this, it would be clear what my intentions were. So we'll do that. So far as these, let's bookmark these. Oops. I'll do that. Okay. So what do I want to do under these conditions? So let's say if the function, or if the object is an int, the function will return the string 0 if obj equals 0. So I'll say if obj equals 0, return the string 0. The function will return the square of that integer if it's even. So I'll say elif obj is even. I want to know if it's even. I'll say obj mod 2 equals equals 0. If obj mod 2 equals 0, we'll return obj squared. And then I'll say else function will return the square. The function will return the cube of that integer if it's odd. So if it's odd, it's just else return obj cubed. Cool. So I have 3 integers to check. Well, no. Well, I've got 0. This should be 0. What am I doing? I can't type today. 0. 4 squared is 16. And then let's do 3 squared is 9 times 3 is 27. Cool. So there's my integers. Those are the ones I have done. So I'll just put these up at the top just to check it out. Let me comment these out. 0, 16, and 27. Okay, good. Looks like we're done on ints. So I'm actually just going to delete this, or actually I'll just put some space between it just so I know it's done. Okay, if the object is a float, the function will return the number multiplied by 1.5. How do we tell if it's a float? What am I talking about? We'll just do the, I was thinking about another problem where you're supposed to convert a float to a string. So if the type of the object is equal to a float, we'll return the number multiplied by 1.5. So if type obj equals float, return obj times 1.5. So let's check our float. That seems reasonable. Okay. If the object is a string, the function will return the string concatenated with itself. Okay, so let's do string next. So return obj plus obj. And let's get our test here. So we should see hello, hello. Hello, hello. There we go. And then let's do Boolean. What do we want for Boolean? If the object is a bool, return the negation of that bool. So just return not. To negate a bool is just to return. If it's true, you return false. If it's false, you return true. So you just return not obj. There's that. False, true. And then let's try it with a list. And we get none. Good. So I hope it was clear this is a good example, kind of a good example um, of the workflow that I'm trying to emphasize and trying to teach. I'm glad I chose to do this rather than wrapping up for the day. Yeah, because I hope it's clear, you know, like this, I want to get to a point where I have some tests, and the tests are kind of like bullet points, or they're like things to just check off, right? Like I have all these tests and I just go through and I test one at a time until I get them all passing. You can run them all at the end if you want, just to, whoops, to make sure. Sometimes I'll do that, but yeah, it makes this nice and easy. I can just like go through and like do this, try this next one, try this next one, try this next one, until they're all passing, and then you sort of break things down into bite-sized problems that way. So that's sort of a what I would consider a goal of a good workflow, is where you have that sort of checklist feeling. And it might seem like it's a little boring, but you know what? Boring makes it easy. You know, if you can make it just kind of straightforward, so your job is to just kind of go through and boom, 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 then you're doing it. It's not there won't be problem solving. It just kind of makes it a little easier. Cool. Looks like they did the same thing. They're just doing it in a different order. For the Boolean, looks like they're saying if obj, which is going to see if it's true or false. So if obj is true, then it'll return false. If it's false, then it'll return true. But looks like the same solution essentially. Cool. Well, that will conclude today's study hall. Thanks to everybody who showed up and hung out and watched and asked questions. I do really appreciate the participation. It makes it fun for me, and I think it makes it useful for other people too. Let me know if you have any questions about what we went over today. Always feel free to DM me if you want to arrange a time to meet, have a one-on-one mentoring session. I'm available for that. Things have really opened up this week from our interview rush that just got over last Monday. So yeah, my schedule is really open. So do feel free to reach out if you want to schedule on a one-on-one. Yeah, I'm happy to help. My turnaround time on Slack can be a little bit long sometimes, but apologies for that. I will try to get back to people as quickly as possible, though. So yeah, y'all have a great rest of your day. I look forward to seeing y'all again and interacting again in future study halls. Do give us a like, comment, and subscribe to our YouTube channel if you want to. I won't push it. If you don't, then yeah, it's all good. But yeah, y'all have a great rest of your day. Look forward to the next stream, and I'll see y'all around. Bye-bye.